Hello students, in this video, let's solve the problem based on the properties of proportion. Welcome to our channel E-kalike. In the last video, we have learnt about the properties of proportion, that is invertendo, alternando, componendo, dividendo, and last is the componendo and dividendo. Now, let's solve the problem based on these properties. The first one is, given a by b is equal to c by d, prove that 3a plus 5b is divided by 3a plus 5b is equal to 3c minus 5d divided by 3c plus 5d. You can see that you have a minus on the numerator and plus in the denominator there. Now let's write what's given in the question. So what's given? A by b is equal to c by d. So I need 3a and 5b. So what I'll do? I'll multiply 3 by 5 on both sides. So 3 being multiplied to numerator and 5 being multiplied to denominator. So what happens? You can see here, that is 3a by 5b is equal to 3c by 5d. Now let's apply componendo and dividendo. So what happens on applying componendo and dividendo? So if I apply componendo, what happens? You get a positive 3a plus 5b. And if I apply dividendo, I get 3a minus 5b, which is equal to 3c plus 5d divided by 3c minus 5d. But what I need in the numerator? I need the negative term on the numerator. So to bring this numerator, what I will do? So I'll apply alternate. If I apply alternando, what happens? If I apply alternando, it gets converted into 3a minus 5b divided by 3a plus 5b, which is equal to 3c minus 5d divided by 3c plus 5d. And this is what we were supposed to prove. So on applying which property? On applying invertendo, so this gets converted into whatever we require. You can see in the question there, whatever I require, I have reached that. And if you don't understand the properties of componendo and dividendo, please go back to our previous video, which was based on the properties of proportional. You can understand the properties of that and you can easily solve the problem. And children, this problem was appeared in the year 2000 for 3 marks. The next problem is, if a square plus b square into x square plus y square is equal to ax plus by whole square, prove that a by x is equal to b by y. Now let's write what's given in the question, that is a square plus b square into x square plus y square, which is equal to ax plus by the whole square. Now let's multiply a square into x square is a square x square, again plus a square into y square is a square y square, plus b square x square plus b square y square, which is equal to, let's expand this. So a plus b whole square, a square x square plus b square y square plus 2ab x into y. You can see this term get cancelled with this term and b square y square get cancelled with this. Now let's write what's remaining, y square plus b square x square, which is equal to 2ab x y. Let me shift this term towards this side. You get a square y square plus b square x square minus 2ab xy, which is equal to 0. You can see this is in the form of a square b square minus 2ab. So I can write this as ay minus bx whole square is equal to 0. So let's apply square root on both sides. On applying square root on both sides, so what happened? Square root on both sides. If I apply square root on both sides, I get ay minus bx is equal to 0. Now I can write it as ay is equal to bx. Now what I need to prove in the question? I need to prove a by x is equal to by. Now let's see here. A, I'm bringing x down here, and you get b divided by y. And this is what we need to put. If a, b and c are in continued proportion, prove that a square plus ab plus b square divided by b square plus bc plus c square is equal to a by c. So the hint they have given is a, b and c are in continued proportion. If they are in continued proportion, how can I write? A by b is equal to b by c. To solve this problem, I am going to assume it as k. If I assume it as k, what I get? A is equal to c. A is equal to b into k I get. Next, b is equal to c into k. Let me substitute this b in a value. What I get, you can see in the place of b, I substitute ck. Again, I have one more k. So I get ck square. Now let me write the numerator a square plus ab plus b square divided by b square plus bc plus c square. Now let us substitute the values. What is the value of a? It is k square, and I have a whole square there, plus a value is ck, and in the place of b, I'll write it as ck again. This is ck square, plus in the place of b, I'll write it as c square k square, because you can see square is there. I've written directly there. So b square again it is c square k square. In the place of b, it is ck. So multiplied with c again plus c square. Now I can write it as c square k raised to the power 4 plus c square k cube plus c square k square divided by c square k square plus c square k plus c square. So you can see in the numerator, I can remove c square k square as common. What remains now? To get k square plus k plus 1 divided by c square, I can remove it as a common here. So what remains? C square plus k plus 1. So this and this get cancelled out, and c square and c square get cancelled out, and you remain with k square. Okay, this is about the LHS what we are talking now. So what is the value of LHS? It is k square. Now let's go for the RHS. Let's see once what is there in the RHS. It is a by c. Now let's take the RHS now. That RHS is a by c. RHS I'm taking now, and I'm going to prove that is also equal to k square. So a by c. What is the value of a? A value is nothing but c k square divided by c. C and c get cancelled and you get k square. You can see here the LHS, it's also k square, and RHS is also k square. Therefore, LHS is equal to RHS. The next problem is, if x cube plus 3xy square divided by 3x square y plus y cube is equal to m cube plus 3m n square divided by 3m square n plus n cube. So this is what is given. We need to show nx is equal to m. So let's write whatsoever it is given in the question. So written this. Now let us apply the componendo and dividendo. So on applying componendo and dividendo, let's see what happens. So I'm going to apply componendo and dividendo. So what happens if I apply componendo and dividendo? So you get x cube plus 3x y square plus 3x square y plus y cube divided by, this is the componendo. Now on applying dividendo, I get 3x y square minus 3x square y minus, plus into minuses, minus y cube. Same thing I do for the RHS also. I get m cube plus 3m n square plus 3m square n plus n cube divided by m cube plus 3m n square minus 3m square n minus n cube. See, you can see this is in the form of a cube plus 3ab square plus 3a square b plus b square. So this is the identity for x plus y whole cube. And you can see the denominator, it is the formula or the identity for x minus y whole cube. Same thing on the right hand side also, it's the formula for m plus n whole cube divided by m minus n whole cube. To remove this cube, what I'll do, I'll apply square root on cube root on both sides. So applying cube root on both sides, what happens? The cubes get deleted and you result with x plus y divided by x minus y, which is equal to m plus n divided by m minus n. Now again, let us apply the componendo and dividendo. If I apply componendo and dividendo, you result with this in the numerator, and the denominator you get x plus y minus x, minus into minuses, plus y. Same thing happens on this end also, plus n plus m minus n divided by m plus n minus m plus n. You can see n get cancelled, minus m plus m get cancelled. Here also you can see y get cancelled, x get cancelled. So you result with 2x divided by 2y, which is equal to 2m divided by 2n. So all the 2 get cancelled and you get x by y is equal to m by n. So what we need to prove in the question we have seen. So in the question it's written that we need to prove n into x. Now let's cross multiply this. On cross multiply I get nx is equal to my, and this is what we need to prove, and we have proved this. Let's go for the next problem. If x is equal to root of a plus 3b plus root of a minus 3b whole divided by root of a plus 3b minus root of a minus 3b, prove that 3bx square minus 2ax plus 3b is equal to 0. So let's write what's in the denominator. See, if nothing is there, I can take it as x by 1. You can see, if nothing is there, I can take it as 1 in the denominator. Let's apply componendo and dividendo. So on applying componendo and dividendo to the LHS, it becomes x plus 1 divided by x minus 1, which is equal to root of a plus 3b plus root of a minus 3b plus root of a plus 3b. You have a minus, so a minus 3b divided by, so I can write a plus 3b plus root of a minus 3b minus root of a plus 3b. Minus into minus is plus, so I get a minus 3b. So how did I get this step? On applying componendo and dividendo. So let me write the LHS same as it is. X plus 1 divided by x minus 1. You can see this term get cancelled with this term. And what I result with? I get 2 into root of a plus 3b. And you can see this term being cancelled out with this term. Now in the denominator I get 2 into root of a minus 3. So 2 and 2 I am going to get cancelled. See, I have a square root here. To remove the square root here, I am going to apply square on both sides. Okay, I am going to square on both sides. So if I apply square on both sides, what happens? X plus 1 whole square divided by x minus 1 whole square, which is equal to a plus 3b by a minus 3. See, the square root and square got cancelled and I resulted with this. Now, see, let me expand the formula. So if I expand the formula, I get x square plus 1 plus 2x divided by x square plus 1 minus 2x, which is equal to a plus 3b divided by a minus 3b. Now let's apply componendo and dividendo to this identity. So now if I apply this, what I get? X square plus 1 plus 2x plus x square. What is there in the denominator? Minus 2x I get, and divided by, you get x square plus 1 plus 2x minus x square minus 1 and plus 2x, which is equal to a plus 3b plus a minus 3b divided by a plus 3b minus a minus into minus is plus 3b you get. See, minus 2x and plus 2x get cancelled, and minus x square plus x square get cancelled. 1 and minus 1 get cancelled. Minus 3b and plus 3b get cancelled. A and minus a get cancelled. Now let's write what's there. X square plus x square is 2. X square plus 2 divided by 2x plus 2x, I get 4x, which is equal to a plus a is 2a by 3a plus 3a is, I'll write it as 2 into 3b. Okay, 2 and 2 get cancelled. See, you can see here, if I take 2 as a common also, you can remove this. I'll show in the next step. If I take 2 as common, I get x square plus 1 divided by 4x. So 2, you get 2 here, which is equal to a by 3. Now let's cross multiply the terms. If I cross multiply this, let's see what happens. If I cross multiply this, I get 3b into x square plus 1 is equal to 2ax. Let me multiply this. 3b x square plus 3b is equal to 2ax. I should arrive at the statement 3bx square. See, if I shift this side, I get minus 2ax plus 3b, which is equal to 0. And this is what I need to prove. Okay, and I